I'm Tom Boutell. I'm with Punk Avenue in South Philly. I'm a partner there. I'm day-to-day I'm with Apostrophe Technologies. We make ApostropheCMS. It's an all JavaScript content management system. So I write JavaScript all day. And I've been doing this for a long time. I'm not a newbie, or to put it differently, I'm old. So I have certainly spent a lot of time using older versions of JavaScript, and I'm certainly as capable as anyone of getting stuck in old patterns. And so I kind of made it a task over the last year or two to keep revising a talk about modern JavaScript features and how they really do make things better and why it really is worth your time to spend some time with them. So I'm going to start with simpler features and get to like a little bit crazier galaxy brain stuff toward the end, hopefully, to try to keep things, as friendly as possible. So I'm going to start by talking about the let keyword and the const keyword and how these replace var. I know we've all been typing var for so long that it's in our muscle memory. Var is terrible, though. Here's a good example of why var is terrible. I have a really simple task here. All I want to do is have my cat variable remain consistent when I'm not in some loop that has its own seemingly totally different cat variable. Seems like a reasonable expectation on my part. This doesn't work at all. And not only does it not work, it doesn't tell you that it doesn't work. Var cat inside this for loop does not actually make a new variable. You'd think it would at least say, hey, I just don't allow that. You can only have one version of this variable per function, but it doesn't. It just quietly is the same variable. And when you get to the end of this loop, you have 10 again. It does not console.log cat, or the name of the cat, like you might expect. So this is terrible. And we've all gotten used to workarounds for this. Like maybe we just take a functional programming approach and we use for each, or maybe we put all of our vars at the top of the function, which if for some reason you have to use var is a good way to stay out of trouble. But there is a much better way, and that is using let. The let keyword lets us say, okay, I want to declare this variable just for this scope. And what that means is that if I use let again inside a nested scope, I'm going to get a new variable. And this is true even if that nested scope is a for loop. So that means that I don't have to worry about side effects, and I can really just look at code at one level to understand what's happening at that level. So when I run this, I'm going to discover that Louis the cat is still where I expected to find him, which is a great relief, and definitely cuts down on bugs and simplifies coding, because this loop has its own version of the variable. If I did not use let, of course, then I would be manipulating the original cat, but I would expect that. Any questions about that? All right, so I'm going to go on to const. The nice thing about let, of course, is it lets you have more than one variable. But the nice thing about const is that it stops you from having more than one, from reassigning to the same variable. So when does this come in handy? When would you want to prevent someone from reassigning to a variable? One reason for that is when you just want to think of that variable literally as a constant and not a variable. It is something that's not intended to be changed, and there may be consequences for changing it that wouldn't be obvious to your fellow developer. Maybe that constant is actually the magic constant that the library you're calling requires you to use, and changing it would have negative side effects. But another use for it is just to have, again, clarity in your programming. If I just go through and start making cats and assigning them to the same variable over and over, I may not notice that I've made the same cat twice with my handy cat constructor here. Whereas, so this is going to go ahead and make the same cat more than once. But if I go to const, if I use the const keyword, then I'm able to say, okay, I would rather that I have a separate constant for each cat. What this does for me is that if I inadvertently make the same cat again, that will actually throw an error for me, which is helpful and helps me understand that I did that I have intentionally or unintentionally tried to assign the same thing twice when that was not my intention. Any questions about let and const? And I think I have everyone's microphone open, so that should be easy enough if anyone wanted to jump in. Okay. All right. I'm going to pop over to the next slide. So let's talk about ES6 classes. Now, I'm not a huge JavaScript prototypal object-oriented programming person. I'm not like a huge fan of it. I find it awkward in a way that's kind of almost unfair, and I could go on for quite a while about why this is fine for most things, but the minute you get asynchronous programming involved, it's not, and it's not really compatible with functional programming, and that's another talk, so I'll stop going on about it. But let me just show you the classical awkward way of making something like an object-oriented class, like a class you might find in Java or PHP, using classic ES5 JavaScript. So you would start by writing a constructor function. And inside that function, when you call, let's say, new cat, what that does is that calls the function cat with a brand new object you can refer to as this. And then you can also assign to the prototype of that function. Prototype is a special property of your cat function, where you can assign functions and even data properties that are inherited. You can think of them as inherited. What really happens is that JavaScript looks up the chain. If you don't have an explicit pet property for an individual cat, it will look at the prototype to find it. This is kind of cool in a cool, nerdy way, unless you're trying to just understand it as someone who's learned programming in an object-oriented way, in which case it's pretty baffling. So let's talk about how we can do this with ES6 classes. These look like the classes that people who grew up on Java or PHP or C++ back in the day would expect. You have a class keyword, you're making a class for cats. You have a constructor function. This gets called when someone types new cat. And in there, you can assign data properties, but you can also, inside your class, you can assign methods. Methods, of course, are functions that you can call with that dot notation like this. These work out to exactly the same thing as we saw in the previous slide. It is, in fact, if you were compiling this from modern JavaScript to, let's say, something compatible with IE11, ES5 JavaScript, then you would find that if you use a compiler like Babel, it will convert this to pretty much exactly the same code you saw in the previous slide. One other funny nuance is that you don't need a comma here. It takes a moment to get used to, but because of the structure, because it knows it's a class, the comma really is redundant, and it is kind of a nice convenience. So this, if you really want to do classical object-oriented programming, this is certainly the way to do it in modern JavaScript if you can. So let's talk arrow functions. Now these, I mentioned functional programming earlier, and for people who love functional programming or who think they understand functional programming, that's really more the category I'm in, to be fair, someone who thinks he understands functional programming, then it is really convenient to be able to compose your code out of functions instead of having everything be nested loops and classes, and to pass functions to functions and all that good stuff. So how do arrow functions help us with that? Well, one of the simplest examples of function-oriented programming, at least in JavaScript, is for each. And this, by the way, just a gentle reminder to anyone who has like PTSD from dealing with really old browsers, you can use this in IE11. It's allowed. And this allows you to iterate over an array and call a function for each element in that array. And that's convenient, and that's not at all terrible. And that's one way to iterate over these fellows. Incidentally, I made a mistake here. I see. I'm so used to modern JavaScript at this point that I use the new string interpolation. I'll talk about that later. This bit would not work in IE11, so I should have used like old school single quoted strings here, plus signs, all that nonsense. But let's look at how arrow functions can simplify this code. Great. So here's the so-called graceful way. We're going to iterate over these cats. We're still going to use for each because it takes a function. We're going to pass it an arrow function. So what is an arrow function? The short way of saying it, which is like almost right, I have to attach an asterisk, is that an arrow function is just a really short way of writing a function where you don't have to use the function keyword, and you can just use this funky little arrow to say it takes this argument and it executes this statement. There are variations on it. I don't show all of them here. This is like the most succinct one. You can, of course, have more than one argument or 0 arguments. If you do that, you'll need to put parentheses around them so the JavaScript can figure out what you mean there. And for the body of the function, you can have a single statement like this If you have a single statement, it'll also return whatever the value of that statement is, which can be really handy if you're calling something like map. But you can also have a more ordinary function body in curly brackets. If you do that, it behaves like a normal function body. You would have to use the return keyword explicitly, but it covers more use cases. So where's the asterisk? What is the way that arrow functions are not ordinary functions? There's one difference. They do not have this of their own. To put it another way, and a really convenient way, inside this arrow function, I can refer to this and it will be whatever object I was in out here. If it was an ES6 class, if I was inside a method, let's say, it would still be that object, which is extremely helpful for those functional programming meets object-oriented programming meets stubbed toes situations that I was talking about earlier. So if you are writing a callback, if you're writing a function that's going to be invoked by an event handler of some kind, or by set timeout, or by set interval, an arrow function will really help you avoid frustrating situations. It'll help you avoid those frustrating situations in Vue. It'll help you avoid those frustrating situations in React. There's a lot of common use cases where you'll find this arrow win. Cool. Yeah, so any questions about the arrow function stuff? And that's one of the bigger topics. Okay, cool. So let's move on. I'm going to talk about object literal shorthand. What this is all about is just the simple inconvenience of saying this kind of thing a lot. I know we've all written code where we have a bunch of variables and we want to shove them all in an object. And it's really obvious when you start seeing the pattern. You've got cat colon cat, dog colon dog, age colon age, size colon size. There has to be a more abbreviated way of doing this. So I'm going to go ahead and show you the succinct version of that. We can just not have a separate key and value. We can just have the property name. When you do that, it is a shorthand that assumes that the key and the value are the same. So it will go find that cat variable in your current scope, and it will put in a property called cat. I see I'm doing a little bit of other interesting stuff with a weight here. I know that's interesting, and I will come to it in a minute when I get to some of the later slides. I'm working on reorganizing this deck to put the async stuff last, because I've come to understand that that's where the true galaxy brain herdy stuff happens for faults. Okay, so let's talk about what we can do to deal with functions that take a variable number of arguments. And this is another area where people tend to start to roll their eyes, thinking about the struggles that they've had with it. If your function takes a fixed number of arguments, you have no problem. You just declare your arguments and you're done. If it takes a variable number, then welcome to the arguments magical object. And inside your function, arguments, you can treat it like an array of all the arguments to your function. There's an asterisk attached to that. There's a bunch of array things that you can't do to it. You can't just call arguments.slice, for instance, because it's not actually an array. So in order to get at those arguments, if you want to, let's say, loop over all of the remaining arguments to the function, you wind up using this syntax. You wind up using array.prototype.slice.call. This is one of those crazy, deep black magic JavaScript things where you're saying, okay, I know I want the slice method, and I know that it lives on array objects, and they have a prototype, so I can get at it, and then I can call it explicitly with the call keyword. I can pass it there. This is pain, and memorizing this incantation isn't doing anything to help anyone be a better programmer or get their work done. So let's look at how we can do this in ES6 JavaScript. Any questions? I mean, for once, this is one of those cases where you just look at it and say, oh, that's all I have to do. ... messages will give you all of the remaining arguments as a single array. And you can treat that array in a normal way. You can call join on it. You can call slice on it. You can do whatever makes you happy. And you can get exactly the same behavior, just so much less code. This is one of the like number one with a bullet modern JavaScript features for me in terms of how much time and effort and lost teeth gnashing that I get from it. So let's talk about template strings. And I cheated and used one of these earlier. Template strings help us with this problem of endlessly writing single quotes and plus signs. Is it the end of the world to write single quotes and plus signs? No, it's fine. You can get by with that. But it is definitely tedious. And it is definitely, more bug prone. It's just a lot of syntax and a lot of hitting shift and a whole lot of nonsense. And it's just not elegant. So let's talk about what template strings can do for us. With template strings, we can just blast those variables into the middle of our template. It is so much more readable. It is much more maintainable. VS Code and other editors will show you what this looks, will show you this visually in a really nice way. It's just a way less bug-prone way to write strings, to the point where I sometimes just write all of my strings with the backtick just to remind myself that it's there and what it can do for me. Also, this is not limited to just being some variable in the current scope. This could be an expression. This could be insane. Don't make it insane, but I won't lie to you. I won't tell you that I haven't written like receipts bracket 0 inside one of these and felt good about it. So there's a time and a place for putting a more complex expression in there. Boop. Okay. All right, so another use of the ... Let's talk about spreading an object. So what was my goal here? My goal here is to, yes, my goal here is to supply defaults. So I'm writing a function called API here, and I want that function to have certain sensible defaults. And it takes an object and some of the properties. Let's say there's the cat property. Well, if there is no cat property, if it's falsy, let's just use Louis. But then we also have priority, and all of a sudden falsy, true and false, like if 0 is false, but 0 is a legitimate value for something like a priority level. So I have a problem here, and this is very bug-prone code, where I have to say, okay, if priority is not explicitly undefined, then I'm going to use the ternary operator and to pick data.priority. Otherwise, I'm going to default to 1. This is ugly. It's time-consuming and bug-prone. But in the end, I do get the right results. I get my my defaults to behave the way I wanted them to behave, but in a really, really tedious way. So let's look at making this elegant. With the spread operator, we can say, here I am making a new object underscore data, and here I am deciding, you know what, for the rest of the properties of this object, I just want you to smash in this other object. It'll just smash all the properties of data right into underscore data, and they will override any properties that are already there. So instead of dealing with the other nonsense, I've said, look, if it's defined in data, I want it. Just give me that. And that is a more sensible behavior for defaults. That gives me the same result a lot more elegantly and with a lot less code written. Cool. Any questions so far? All right. So I'm going to move on to unspreading and object literal assignment. So what's happening here is I am interested just in one property of this cat. I only care about the cat's name, but I had to get the whole object, and then I have to write info.name. I know this doesn't seem bad, but when you have many more properties potentially in there and you're only interested in 2 or 3, it's a lot of get the object and write this.this, this.this, this.this. So I can use so-called unspreading to pull out properties of the object that I'm actually interested in. I can write const curly braces name equals get cat info. When I do that, I now have just the name pulled out as a constant, and I don't have to type cat.name, info.name, whatever, over and over to get at those things. This can be really handy, and it can also be really handy when you use something very like it for arguments. I'll show you that in a minute. Yeah, so I really love this one as well. This is one of the big teases for me that made me say, okay, I have to have this. So unspreading arguments. I'm interested in writing a function that takes some options. We've all written functions that take options, and there's a lot of options. And we all know that you should not write functions that take more than about 3 named arguments because people will not remember the order of them. After about the 3rd argument, you're making things difficult for yourself or more likely for someone else. So the better solution to that usually is to eventually have something, you find yourself writing this, options, and then you're pulling properties off of options like options.style, options.size, options.this, options.that, and that you can let that grow more. And you wind up documenting those options up here because there's really nowhere else to put it. So in this case, I have options.style, which helps me decide how I'm going to display the messages. So how can we use modern JavaScript to make this more elegant? Well, how about this? We can use unspreading for arguments, and so we can say, rather than just saying options here, we can actually go ahead and kind of deconstruct that options object right in the declaration of the function. And this has done some really beautiful things for me. One is that I don't have to type options.style down here. But more important, I think, is that it's self-documenting. My comment is gone, unless I actually need to explain how styles work, of course. But basically, my code is now self-documenting. I can have this comma-separated list of options. This is very much like being able to pass arguments to a function by name. It feels like it. There are some languages like that where there's a syntax for passing arguments by name. We're pretty much getting that benefit, but in JavaScript, which is a beautiful thing. You've probably noticed that everything that I've shown so far kind of translates in a simple way to older JavaScript. And that's not a coincidence. Just about everything that happens in modern JavaScript starts out as a transform in Babel, in the JavaScript compiler that people use to be able to run modern JavaScript in older browsers, or really bleeding edge JavaScript even in new browsers. And that's no bad thing. And it means that it's usually pretty easy to wrap your head around what these new features are doing, even though they're making your code a lot easier to follow.
Hey, Tom.
Yes.
On that example with style, do you know a way to potentially rename those arguments as they come in, or do they need to stay the same as the object properties?
Well, rename them differently from what you see here in the declaration of the function.
Yeah, so like as an example, maybe the options that come in the option object itself, style may make sense for that style of that object, but inside this function, we may want it to be tag style or.
Oh, I see.
You see what I mean?
Yeah, I mean, I think, but you're saying that in the function that's calling it, you'd rather just pass it as style. That suits better in that context.
Well, mostly worried about the name of the thing really matching what the argument is that comes in. So in this case, I'm not quite sure what the style, the thing is that I'm trying to style. You see what I mean?
Right. Right.
So it might be useful to rename somehow. I don't know if there's an easy way to do that or not.
Yeah, well, I mean, first of all, this could just be tag style, and you could use tag style inside the function, of course. But another way to deal with it, if you really wanted like the self-documenting thing to differ from the name that's used inside the function, is that you could use tag style here, and you could start this code off with const style equals tag style, or something to that effect, so that you wouldn't have to use the same syntax in both places if you didn't want to. Does that make sense?
But the name you use in the function declaration needs to match the property of the object you're passing, correct?
Yes.
Okay.
Yes, and so that's it. This still, the signature of this function is not different from the previous one, where you had to pass, where it just says options, and you got to pass in an object and read some documentation, figure out what the potential properties of that object are. So all that we're doing here is we're making that self-documenting by saying, yeah, you're going to pass an object, and one of the properties you can chuck in there is style. And so that's up to me as the person writing this function to name these properties any way I would like to. And the person calling does have to pass those properties so my function knows what it's receiving.
Okay, thanks.
Sure. Okay. So one thing that might be logical to ask there is, what about default arguments default values for arguments? In particular, for something like that object we just saw, that options object, you probably would like to have a default style. You probably have defaults for most options, because the idea is usually that you don't have to pass 48 of them or something's not good in your code design. So how would we give a default to an option? Well, in ES5, you might write if message triple equals undefined, message equals meow. That's one way to make a default. Make a default happen. It works, but if you have a lot of options, this gets unwieldy quickly. So if we look at this in modern JavaScript, we can just write a default right into the function declaration. And again, this is self-documenting. I don't have to have a big comment here saying the default value for message is meow. It's apparent both to me and to the person who's calling my function. So this also goes a long way. And if I was using that unspreading syntax that we were looking at a moment ago with style being inside an object, I can do it there too. So I can give all of my options a default value, which really eases the pain. Moving on, accessing stuff that might not exist. Yeah, so this is a newer thing. I think, 2017 or so. JavaScript moves fast now. That's something that also, as an old head, that kind of blows my mind. JavaScript used to move very slowly because you were stuck with Netscape, then you were stuck with IE4, then you were stuck with Firefox, but Internet Explorer was still kind of stuck on IE6 level and not getting better. But then we got into this modern browser era where everyone, including Microsoft, tried much harder. And the evolution of what's supported in browsers was much faster, and the evolution of what's supported with Babel is like light speed. So a lot of pain has gone away more quickly than you might expect. And one of the classic problems that I run into is coping with things that might not exist. In particular, let's say that I'm interested in, I've got a message. That message was spoken by someone. That person might have a job, or they might not. That person might have a job title, or they might not. If I just try to write message.speaker.job.title and they don't have any of those things, crash out. That's it. And we've all crashed with that code because it's so tedious to write this and this and this, which, by the way, this in itself is a nice trick to know. The trick here is I'm taking advantage of the fact that and will return the value of the last thing. Of course, and will not be truthy unless both things are truthy, but it will turn the last truthy thing, which, if that's not the novel of a self-help book for programmers, then it really should be. So this is in itself a really convenient thing to know. But it is still tedious to have to write this chain like this. And you see how I made this work for my two cases here without crashing. Undefined is correct. There is no job title for the second person. But now let's look at making this more elegant in modern JavaScript. We can now write question mark dot. I love this. It's taking my fingers time to get used to it. I think I'm guilty of still typing, double ampersand chains in some cases, but I'm working on it because this is a gorgeous thing, to see this go away and to be able to just say, look, I don't want to crash here. Undefined is an acceptable final result for me, but this is where I'd like to get to if I can. And that just saves, a tremendous amount of time and pain. Does that make sense to everybody? Cool. Alrighty, so let's talk about iterating over objects. I added this slide this morning because this is one of the things that I do very often. To be clear, I'm talking about not just iterating over an array, but iterating over an object that has a lot of properties. And each of them, has a key and a value. And I'm interested in walking all the way through that list. Why would you need to do that? Well, sometimes you're going to receive a whole mess of attributes, for instance, the attributes of a person. You just want to format them all and spit them out for debugging purposes. Or maybe you let people configure things using objects because it's a little more terse than making them pass an array with a name property for each element. There are a lot of situations where you might iterate over an object. By the way, back in the day, we also all remember that we were always told, never do that because you can't trust the order of the properties in an object. They might come out in any order. This is not true anymore. There is a defined order for the properties of a JavaScript object. You can look it up, and it is something you can rely upon across browsers and in Node and all modern JavaScript implementations. So I'm going to iterate in the old IE11 friendly way over my data object here, some data about my kitty. I'm going to use object.keys to get an array of keys, and then I'm going to run for each over that. This isn't bad because this is, IE11 stuff, and I'm always reminding folks, IE11 is actually not the worst thing in the world. It is, by the way, the last bad thing in the world. IE11 is like 2 or 3%, depending who's looking and who's asking. It's not irrelevant, and it is some of your customers who are suffering the most and who deserve your help, and it's worth babblizing things and making things work for them. Yeah, so this will iterate over those keys and get me at those keys, and then I can pull them out. There are other things that people will do. People will use the old for in operator. The for in operator is usable in some situations. I don't like keeping track of those situations. It has to do with the fact that when things are objects of a class, you're going to have issues with it pulling out properties that are inherited that you weren't interested in. It can be problematic. So I would prefer this syntax for sure if you're stuck writing ES5, but you're not. So let's talk about doing this in modern JavaScript. And I'm referring to this as deconstructed galaxy brain, because the first time I looked at it, my eyes just bounced off. And the second time I looked at it, I said, oh, that's cool. But there's like 3 modern features in one line of code here. So let me break it down a little bit. Object.entries. This is a newer method of object. You hand it an object and it returns an array. That array, each property of that array is a little array with a key and a value property. Like array 0 is the key, array 1 is the value. First time I read that, I said, F that, why did they do this? It's like, there has to have been a cleaner way to do this. Couldn't have been .key and .value. Couldn't have been, well, the reason why they did it is because it plays really nicely with another new feature, which is array deconstruction. I was showing earlier how you can use that, you can spread out object properties. You can do the same trick. You can do similar tricks rather with arrays. If I am assigning an array to something, I can assign it to like a little fake array like this with a couple of variable names. That will create those variables as the first element in the array, element 0, the second element of the array, element 1, and so on. So, and by adding const with that, so I'm going to make a couple of constants, key and value, for each iteration through this loop. The third cool new feature in this one line of code is of. The of operator, or the of statement rather, is used to iterate. Just a sec, guys. We've all done this on a conference this year, right? Okay, so cool. So I am going to iterate over the array that I got back from object.entries. I could do this old school with like for I equals 0, etc. I could do it middle school with for each, and that wouldn't be bad. But the nicest way is this of statement that allows me to just iterate over all the values that are coming out of this array without having to keep track of them, without having to create an arrow function or use for each. It's a really graceful way of iterating over an array. It also sets us up really nicely to do cool tricks when we are doing asynchronous programming, which I'll come to in a minute. Any questions before I move on? I know there's like 3 crazy things in this one line.
Yeah, I'm kind of curious if there's an implicit let occurring in those final 3 lines with key and value.
There's a const. There's an explicit const occurring.
Gotcha.
You could put let here, and then you would be allowed to play with key and value inside this, which you might in some cases. These could also be variables that already exist, like let. They could have been declared with let, and that would be fine too. But usually I find myself writing this.
Gotcha.
Where these are throwaways. Cool. So let's talk about keeping only the unique values in an array. I threw this slide in today too, because I used to do this a lot, and now this is like, I did it, right? I wrote the thing. Like this will take my array, which has an extra Louis, and it will join that array to show you, all of them. And then I'll do the thing where I iterate over it, and I want to keep only the unique ones and not keep any duplicates. So, okay, for each one, I use index of to find out if it's already in the array. And if it isn't, I push it on new data. That's great, and it works. Now you don't do this, right? You probably use a library like __ or underscore to do this, even if you're using ES5 JavaScript, because it is, it's tedious, and because it's, always bug prone to write your own boilerplate yourself, unless you maybe have your own little library where you do this kind of stuff. But in modern JavaScript, there is another way to do it. So I'm going to use sets, and I am going to use sets in the laziest way possible. Sets are a whole new feature of JavaScript, this new class of objects, set, that you can use to manipulate sets rather than arrays. You know, the whole definition of a set is that each thing can only appear in it once. And you try to add it again, that won't happen. And that's cool. And it has its own API, and I don't know it. I haven't bothered with it. You know, I've gone merrily along using arrays to get work done in JavaScript, like we all do. But there's one use case for it that is really sweet. And again, I combine two features just to have a little bit of fun. I am going to take my existing array of data. I'm going to make a set, and then I'm going to use the ... array operator like this, the unspreading of an array, to say, hey, take this thing, which has to be array-ish. It has to be iterable. And sets are considered iterable. And please just make it the remaining elements in my new array that I'm making here. So I just took this set and flattened it out into an array. If that is a little too weird, you can call array.from and pass it a set. That will work too. 1 second. Okay, look at that. My co-host has finally decided to join us. Very noisy about it. So this is a really handy way to eliminate duplicates. And it's also a good time to mention, if you're still reaching for Lodash or underscore, I think I've encountered a few cases. I really should make a list of the cases where I still reach for Lodash or underscore, but most of the time you don't need to. So it's worth asking, like, am I missing a modern JS feature that I could use instead of dragging a whole library in? Cool. So I'm going to briefly talk about one more topic. Then I move to the end because I know it's the craziest for folks who don't do asynchronous programming all the time. But I want to talk about async await. Now, in ES5 JavaScript, when we deal with things like event handlers or remote APIs, especially if we're doing something like calling an API, something that might make an AJAX call to the server, fetch some data, or if we're doing Node.js programming and we're trying to get anything at all done, like talk to a database or insert something or send something, you know, over a network. It's always involved a callback. Now, most of us have probably moved on from callbacks to writing promise chains. Even in ES5 JavaScript, it's a very clever solution that was invented to say, you know, we can write this almost like it's normal linear code, because the big problem with callbacks is you get this crazy nested pyramid of death situation. In this callback, I'm going to do the next step, and then in this callback, and you get this diagonal thing going down, and the odds that you're doing any correct error handling rapidly approach 0 at that point. So we all started using promises. So now I'm going to call the first function. It does not return a reversed version of my strings. It returns a promise to reverse it later, because let's pretend that reversing things is hard and that we have to call a remote API to do it. More realistic would be like fetching some data from YouTube, let's say, or inserting something in a database or what have you. So, okay, now I've got my reverse data inside this then function, because this is the callback that gets invoked when it's done. And I can do another reverse, and then will be called again, and so on. So I can create this chain, and at the end I can call .catch, which is just like using an exception handler, only for promises. So a lot of us have seen this before, have worked with this before. It does work, and it was an improvement on raw callbacks, but it's still pretty painful. So let's look at how modern JavaScript puts this together. Damn, I mean, you know, that's a lot nicer. So all we have to do is declare our function async. And each time we want to invoke something that returns a promise, we, instead of typing .then and .catch and so on, we just write await. If one of these promises is rejected, if we don't have a try catch in this function, and some other async function is awaiting us and it has a catch block, great. The exception, the error that was rejected from the promise will wind up in that catch block, just like normal code. And this is the point where a lot of JavaScript developers started actually learning how exception handling works and how catch blocks work, because they had never used it, because what they had been drilled into them is, don't use it, it doesn't work. It doesn't work because you were probably trying to call an async function, a function that involves callbacks, and that doesn't do what you think it does. It doesn't return the value that you want. Now you can have the value you wanted. You can just await it, and you can write code that would be familiar to someone who's used to getting things done in a language where saying, I want to do thing 1, thing 2, and thing 3 in 3 steps is normal and allowed behavior. Crazy expectation, I know. So we can get the same result with just infinitely less code. And just one more little note on that. Rate limiting is a thing that comes up a lot with APIs. You don't want to make a million calls to a server at once. Let's say that we have 2 cats and we want to reverse both of them. And the API server we use for the super hard job of reversing strings, it can handle 2 cats at once, no problem. So we get through that step. And I'm doing this ES5 style plus, let's say I've got a promise library. I would have had to haul that into IE11 already. So I'm going to do promise.all and to take all the promises for reversing these. I know that this is hard to follow. It's like this is the map trick for making a promise for each cat, and then you're going to await all the promises at once. I'm going to hit the rate limit when I try to do it for 3 cats, because let's say the server limits me to only 2 requests at a time. You know that YouTube and many other APIs limit how many requests you can make at once, and you can hit these API limits really easily. So let's do this with for of. In an async function, for of can have a wait inside it. Just like roll that around in your brain for a second. I can await inside a for loop. That means that only one thing will happen at a time, and I will never get in trouble. It's a beautiful thing, and this is what I almost always do. If I need to do 100 things, I do not try to await all 100 promises at once. Like, I don't show off in that way, because I have no idea what the rate limits of all the things that I'm banging on are. I would rather do them one at a time. If I'm writing something like a Node.js application, then I would expect that I'm getting plenty of parallelism from the fact that like 1,000 people are hitting my server at the same time anyway. And I don't really need to process 100 things per person at the same time. If I do need to process a lot of things at the same time, by the way, you can use the Bluebird promises library. It has a very nice promises.map function that you can give a limit to. So you can say to it, it's okay to process 3 things at once, but don't go past that. So any questions about the async await stuff? I know it's a big topic. All righty. So I should be wrapping up, and I am. I wanted to give you a picture of Louie the cat because I've been talking about Louie the cat for the last 45 minutes. He is in fact enormous, as you can see. I did give you a promise for him, so I figured I should resolve that promise by the end of the talk. Any last thoughts or questions about the topic? Cool. Appreciate the emojis. Yeah, so, and for 1 minute, this is where I work. I work here, and we write JavaScript all day. If you are interested in writing JavaScript all day, we hope to be hiring again in the near future. And we also make a heck of a CMS that you might want to check out. It is open source. So, hey, thanks for coming to the talk. Looking forward to yours.